Bismillahirrahmanirrahim. Assalamu alaikum. My name is Iman Salima. I am from Department of BS Biotechnology. My ID is 015. Today I will discuss about GCMS, which is abbreviated as gas chromatography mass spectrometry. First of all, I will discuss what is interface in GCMS. The pressure incompatibility problem between GC and MS was solved by inserting an interface. Interface join GC with MS. There are many interfaces like jet electrospray, thermospray, direct electrical ionization, moving wire, or belt interface. What are the types of interfaces? The types of interfaces includes the following: capillary direct interface, jet separator, which is also called column pack, and last is Watson Biermann effusion separator. What is capillary direct interface? Today, most GCMS systems use capillary columns and fused silica tubing formats and inert high efficiency direct transfer between the two systems. The flow rate between capillary direct interface is 5 ml per minute. It is easily can see that these are the analyte molecules and these are the carrier gases which are flowing in capillary tube. This is the flow column flow from GC to the MS. Next is jet separator column packed. The separator consists of two glass tubes aligned with a small distance between them. Carrier gas entering from the GC column is pumped away by a separate vacuumed system. The larger sample molecules maintain their momentum and pass preferentially into the second capillary. Sample enrichment occurs and the initial atmospheric pressure is reduced. In this diagram, both T and P surfaces activity of the glass jet separator must be controlled. Next is Watson and Biermann effusion separator. It consists of sintered glass tube. The carrier, usually helium, passes preferentially through the center glass tube and the effluent is concentrated by a factor of up to 100. The gas flow rate in the order of 20 to 60 ml per minute. Next is what is the ionization source? It converts the components of a sample into ions by bombardment with electrons ions molecules. In ionization, CH3OH gives one electron and produces CH3OH ion with two electrons, which are molecular ion or radical ions. The gas molecules existing in the GC are bombarded by high energy electron beam. An electron which strikes a molecule may impart enough energy to remove another electron from that molecule. The charged molecule is known as molecular ion. The molecular ion can cause that ion to break into smaller pieces. CH3O positive H ion produces CH2OH positive ion with emission of hydrogen ion. Next is what are the ionization techniques? Ionization technique includes the electron impact, chemical ionization, and negative chemical ionization. What is electron impact? The most common form of ionization is electron impact. Electrons are produced by tungsten filament. These electrons accelerated towards the ion source chamber. The electrons require an energy equal to the voltage between the filament and the ion source chamber. 70 electron volt is commonly used in the electron impact. A proportion of electron beam will strike the electron trap, producing trap current. This is the diagram which shows the parts of the electron impact. A permanent magnet is positioned across the ion chamber to produce a magnetic flux in the parallel to the electron beam. A positive ion repelled voltage and negative ion excitation voltage works together to produce an electric field in the source chamber, such that ion leaves through ion exit slit. The ions are directed to the various focusing and their centering lenses are focused on the source exit slit. Next is chemical ionization. In chemical ionization, a reagent gas, methane and or ammonia or isobutane are introduced in the mass spectrometer. The reagent gas will interact with the electron to produce radical electrons. Next is negative ion chemical ionization, which is abbreviated as NICI. In negative ion chemical ionization, a reagent gas is used and the electrons collide with it so that the energies are reduced to 10 electron volt. Molecules with a high affinity for electrons are able to capture these low energy thermal electrons. This is known as NICI, but it does not involve in the formation of a chemical adduct. What is the working of a GCMS? The gas chromatography works on the principle that a mixture will separate into individual substances when heated. Sample introduction into gas chromatography inlet vaporized at 25 to 50 degrees Celsius and swept into the column NY helium carrier gas and separated on column. Sample components emerge from column flowing into the capillary column interface connecting the gas chromatography column and MS. Helium is removed. Identification of a compound based on its mass spectrum relies on the fact that every compound has a unique fragmentation pattern. The computer drives the mass spectrometry, records the data, and converts the electrical impulses into visual displays and hard copy displays. As each solute exits the gas chromatography column, it is diverted into a mass spectrometer, which is capable of both monitoring the amount and identifying the chemical nature of solute. In this way, both quantitative and qualitative information about the mixture can be obtained. The sequence and the relative intensity of the mass peaks gives information about the chemical identity of solute. The absolute intensity of the peaks provides information about the amount of substance present. Next is the interpretation of results. Through gas chromatography, a chromatogram is obtained. Through mass spectrometry, a spectrum is obtained. Gas chromatography mass spectrometry gives a 3D graph which has both chromatogram and spectrum to each separated component in chromatograph. On y-axis, it represents intensity or abundance, and on x-axis, it is retention time. What are the limitations of GCMS? Only compounds with vapors pressure exceeding about 10 raised to power 10 torr can be analyzed by as chromatography mass spectrometry. Certain isomeric compounds cannot be distinguished by mass spectrometry. For example, naphthalene versus azulene. What are the applications of GCMS? Applications of GCMS includes the pharmaceutical applications, impurity profiling of drug molecules, environmental monitoring and cleanup, criminal forensics, law enforcement, food, beverage, and the perfume analysis, astrochemistry. Next, I will explain the applications. Pharmaceutical applications, elucidation of the structure of organic and biological molecules, impurity profiling of pharmaceuticals, identification of compounds in thin layer and paper chromatograms, identification of drugs of abuse and metabolites of drugs of abuse in blood, urine, and saliva. Testing for the presence of the drugs in blood is in race horses and in Olympic athletes in forensic GCMS. The analyzer of aerosol particles, the determination of pesticide residues in food, polymer characterization, pyrolysis method combined GCMS. Drug monitoring and toxicology studies, determination of amino acid sequence in sample of polypeptides and proteins. Impurity profiling of drug molecules. Impurities can arise from manufacturing process, degradation of drug substance. If impurities are greater than 0.1% concentration in drug substance, the name and structure of impurity is to be submitted to regulatory agencies. US FDA considerations. Impurities should be less than 1%. Presence of impurities must be illustrated with gas chromatography, mass spectrometric chromatograms. Next is environmental monitoring and cleanup. GCMS is becoming the tool of choice for tracking organic pollutants in the environment. The cost of GCMS equipment has decreased significantly and the reliability has increased at the same time, which has contributed to its increased adoption in environmental studies. Next is criminal forensics. GCMS can analyze the particles from a human body in order to help link a criminal to a crime. The analysis of fire debris using GCMS is well established, and there is even an established American Society for Testing and Materials standard for fire debris analysis. GCMS is especially useful here as samples often contain very complex matrices and results used in court and need to be highly accurate. Law enforcement. GCMS is increasingly used for detection of illegal narcotics and may eventually supplant drugs sniffing dogs. A simple and selective GCMS method for detecting marijuana use it was recently developed by the Robert Koch Institute in Germany. It involves identifying an acid metabolite of tetrahydrocannabinol TAC, the active ingredient in marijuana, in urine samples by employing derivations in the sample preparation. GCMS is also commonly used in forensics toxicology to find drugs and or poisons in biological specimens of suspects, victims, or the deceased. In drug screening, GCMS methods frequently utilize liquid-liquid extraction as a part of sample preparation, in which target compounds are extracted from blood plasma. Sports anti-doping analysis. GCMS is the main tool used in sports anti-doping laboratories to test athletes' urine samples for prohibited performance-enhancing drugs. For example, anabolic steroids. Food, beverage, and perfume analysis. Foods and beverage contain numerous aromatic compounds, some naturally present in the raw material and some forming during process. GCMS is extensively used for the analysis of these compounds, which include esters, fatty acids, alcohols, aldehydes, terpenes, etc. It is also used to detect major contaminants from spoilage or adulteration, which may be harmful and which are often controlled by governmental agencies. For example, pesticides. Astrochemistry. Several GCMS have left Earth. Two were brought to Mars by the Viking program Venera 11 and 12, and Pioneer Venus analyzed the atmosphere of Venus with GCMS. The Hygiene probe of the Cassini Hygiene mission landed one GCMS on Saturn's largest moon, Titan. The MSL Curiosity rover sample and analysis at Mars SAM instrument contains both a gas chromatograph and quadruple mass spectrometer that can be used in tandem as a GCMS. The material in the Comet 67P gas was analyzed by the Rosette mission with the GCMS in 2014. Medicine in bond errors of metabolism are now detectable by new bond screening tests, especially the testing using GCMS. It can determine compounds in urine even in minor concentration. The measurement of C13 C12 ratio with an isotope ratio mass spectrometer. By concluding, GCMS is one of the best analytical tools in analyzing most of the compounds. GCMS as an analytical method of option is its increased sensitivity and reliability even in very small quantities. That's all from my side. Thank you.